So what we're going to talk about is the transformation of the functions. And so what I wanted to show you is, let's see if I can bring it up really quick, is the sheet that this part is part of the sheet that I gave you guys as well. And this is how things change within the functions depending on, oh, where is everything going? Well, this one here. All right. Now, I'm going to try and click on it, see if I can make it bigger for you without showing you me. There we go. Nope, that's not the right one. Let's see if I can go back. Dang it. Because what I really want to show you is how the points change, right? So say, well, I'll just talk to you about it and show you. You guys can go find the worksheet yourself. So say we have this function right here, f of x equals x, right? If I have f of x equals x or y equals x, there's all sorts of things that we can do to this specific function. And what it's going to do is it's going to change the points, right? On this one, what we're saying ultimately is that y equals x, right? So if I have these points, x and y, right? We have all these different points, x and y, but what if I change those points around? I really want that worksheet up. So if I'm changing these points around, what I want you to think about is what's going to happen based on what I do to the function. So we have different translations, and we're going to be focusing mostly on what we call a vertical translation, which is if I have a function, right, and I change it, if I go f of x, dang, I wish that picture didn't disappear every single time I touch the screen. F of x equals x. Well, in this case, it says plus d, but let's just say plus 3, right? So say that's my transformation. All a transformation means is I've done something to the ultimate equation here, right? And what I did in this case is I added 3. Now, I didn't add 3 to the whole thing, right? I just added it to that final value. Notice right here, it says I've got f of x translates to f of x plus d. Well, we're saying that in this first one, we're saying that f of x equals x, right? So f of x and x would be interchangeable, right? They're equal to each other. So it's like I'm saying that f of x is being translated, right, to f of x plus 3. I'm taking what f of x was, which was my parent function, and I'm adding 3 to it. So whatever the result is what I'm adding 3 to. I'm not changing my input value. I'm not changing my x, is what I'm trying to say. What I'm changing is the outcome, the y. So for every point I have here of x, y, the translation would be my x values are staying the same, but I am adding 3 to my y values, right? And that's what's going to happen with every point, which means if I'm changing my y values, if I'm adding or subtracting something to my y, it's going to adjust how it shifts up and down, right? It's not going to affect how it shifts left to right. It's not going to shrink it or make it bigger. It's going to determine how it moves up and down. Now, what I would like to be able to do is on top of this, be able to show you what that looks like graphically. So if I have f of x, or s, f of x, equals x plus 3, what's that going to look like on a graph? And notice it's the same line. It follows the same line on that graph, right? The difference is where each point is going to move up 3 on the y. So in this case now, here when x is 1, when y is 1, x is 1, right? X is 1, y is 1. Now, when x is 1, y is 3. Right, well, that's 2 right there. Right, so everything's going to shift up 3 units, right? So that's all I really want to talk to you about. I think he explains it so much better than I do, but I just want to show, I want you to see, understand how it's changing the points. I'm not as concerned with how it's shifting because he's going to show you how it's shifting, but what I want you to see is it changes every single point on that graph, right? We're adding 3 to every y value before. Before x and y were equal, now we're going to add 3 to every point on that y. And that would be true too if we were using the function x squared, right? I want to get rid of this one, right? So here I have the parent function of x squared. If I add 3 to that x squared, if I make this x squared plus 3, what we're saying is that for every point x, y that we had in the original, it's going to translate to x's will stay the same, but we will add 3 to whatever our y's were, right? So if I were to actually put in this function, it's going to raise everything up 3 units. At every x value, you're going to have a y value that's 3 units higher. So I'm going to type that in and show you what it looks like. F of x equals x squared plus 3. So it shifts everything up 3 units. Now that's what happens when we're changing the x, but sometimes, when we're changing the y. Sometimes, though, that change is going to happen on the x, and that's what I want to show you the difference of. So in this case, I just showed you f of x plus 3. We changed the y, right? We had x squared plus y. What happens, though, if I change it to x plus, oops, that's an equal, x plus 3 in parentheses, raise the square, that's a lot. So this time, if you notice, with this, I put in x plus 3, and then I squared the whole thing. I am now changing what's happening to the x instead of what's happening to the y. And when we're changing what's happening to the x, we're moving left to right. When we're changing what's happening to the y, we're moving up and down. And so in this case, when I when I do the change on this, right, my original xy that I had from the first one, from the parent function, for every point xy now, it's going to shift, and I'm going to have x plus 3. Whoops. Comma y. So our y's aren't changing. We're not going up and down with this anymore, right? We're going left to right. Notice this. This is a very important part, is I said plus 3, but I moved to the left, right? It moves my graph to the right. If this was negative 3, if it was minus 3, it would move it to, it would move it to the right. This time it moves it to the left, right? So when we have a positive change on our x, we're moving in the negative direction. When we have a negative change on the x, we're moving in the positive direction. Our shift is different. So what I want you to pay attention to is when you have this, and you can have this open next to you when you guys are doing the assignments, right? There's no need to have to memorize this, but pay attention to what's happening to each point, right? Because you can easily make a graph of these, right? Here I'm changing my C. It's telling me that I add C, a value of C, whatever that number is. If C was 3, right? If we had X minus 3, well, then we would add 3 to each side. If we had X plus 3, we would subtract C from each side, because notice that's how we're playing on it. The only other thing I want you to see on this before I send you away and have you guys watch the video on it is what's going to happen. So we've got our x squared, right? We've got the green line, which is our parent function. If I put a negative on this x, it is just a rotation across the x-axis, right? Now, keep in mind, I am doing this on our outcome. I'm not doing it on, right? I'm doing it on this side of the equal sign. I'm not doing it on our y. It's not grouped in with the x. So it's happening to our final value, right? I can put any number I want in for x, and that solution is going to flip over the x-axis. If I did it on the x itself, so if I, oops, parentheses, negative parentheses, now it's, oh, that is a weird parentheses. There we go. So now I've got the negative on the x and not on the outcome on the y. And so it's a shift left and right. Actually, you can't even really see this shift because it's a flip over the y-axis, right? Which is identical. If I did it here, you could probably see it better, right? If I put the parentheses, let me clear this off. Let me clear my screen really quick for you. Let's see. I want it so that you can actually see the rotation. So if I went ahead and cleared this, what else do I have that open? Right. So this is my parent function here, right? What if I created a change on that where I had f of x equals, that's not an equal, that's a plus, equals parentheses negative x, so that we're changing what's happening to the x, not what's happening to the y. And notice that it is just a flip over the y-axis. It's a mirror image, a reflection over the y-axis. We took this and we just flipped it, right? If this was on the outside, if this negative was on the outside of the parentheses, then it's happening to the y. It's going to look the same in this circumstance, though, because either way you flip it, because it's a straight line. Cube, it probably shows the best, but I think you guys get the idea. What I want you to pay attention to is on that sheet that I gave you, it tells you how to change your X and Y, right? Whatever you have for X and Y, this is going to be how it changes your X and Y points. It's going to change every single X and Y point by that much, every Y value. So you can pick certain points. I was going to show you, but I stopped sharing my screen. So I want you to just keep that in mind. It changes every point in that fashion. Have those sheets open to you when you're doing your work, because you can actually see how the points are going to change. You can take any point on the original and it'll tell you how to move it on the others. So watch the video, do the assignments. Please come back with questions if you don't know how to do something. Because I need you to understand this portion. Pretty soon you're going to have a quiz on it. There's a lot of people that are behind in assignments. I keep your assignments nice and short so that you don't have to fall behind. And I know that some of you are getting overloaded in some of your other classes, but I will not overload you. So don't let this one fall behind, because if you do let this one fall behind, it's going to seem overwhelming when you try and do it all at once. But your assignments in this class are really short, and I'm trying to limit them for you so that you don't get overwhelmed, because I've heard from a lot of students that some teachers are just really like laying it on thick with the amount of work that you have to do. So I'm trying to limit it for you so that you don't have a ton of stuff that you have to do. But if you don't do it, it's all going to seem like a ton of stuff if you've got to do it all at once, right? And I don't want you to get there. I'd rather you guys do it in a timely fashion when it's easy, like right after we've met. Like this, you guys haven't watched the video yet, so it was hard to make this stuff seem great for you. I should probably stop recording this because you don't need to see all this in the video.